Today we will like discuss about the trusses, start about the definition, and we will talk about what is the importance of truss, what is the importance of frames, what is the importance of machine, how all of them are interconnected. Now, when you try, like in the last class, like when we started this course, we discussed about how force is acting on first of all a point mass, then a rigid body. It means that we started with the application of forces on a single body. Yeah. However, if you see the trusses, frames, or machine, they are nothing but they are a connected bodies. They are combination of many bodies which are connected together, either support some kind of load or to like when one of its element starts moving, we call it as a machine. And let us try to first understand what these and frames and machines are. First of all, forces. The forces are of two kinds. External and internal. The external force, we have discussed about how the external force on a body, like if there is a point mass, let us say m, how the force m, which is an external force on this body, acts. So what will be the consequence of this? A rigid body, which is a combination of many point mass, and when some types of forces are acting on it, let us say like the F2. This is what we have discussed in the previous class. How the forces on either one point mass or on a rigid body here point mass x. Now when you see that, when we have to find out the external forces on the combination of these bodies, for example, let us say you are having some system which consists of many members such as so here if you try to separate all these members like this, you will try to see that it will be having some kind of force. Let us say this is your F1, F2, and this one if you draw, having some forces F4. So right now we are just taking a generalized case where these forces are specific in terms of so what one can see over here is, if right under this condition, if one sees there is no external force acting, but when you separate out each member will be having F4 and F3. However, in this case here, if you just give this particular case, F1, F2, F4 and F3 are external forces. This with respect to body 1 and body 2, respect to body 1 and 2. However, when you try to deal with the connecting bodies, this is the connecting, and this is one complete system. For this is F1 and F2. So for complete system, F1, F2, F3, F4 and F they are called the internal forces which will help to keep all these members under static equilibrium, or these forces will help to keep all the connective members in contact with each other. So such kind of forces for the complete system are called internal forces. Okay. In a similar way, even for one complete member, you can try to have what is the internal forces in this. So if you just subtract, if you just try to see what force exists at the section, for example, like this. Here, let us say there is some force P. So in this case, you can call this P as internal force and F as external. Similarly, for connecting members, you will call this P for this system, F1, F2, F3, F4, all are your internal forces. However, P is called external force. So what is the importance of internal forces in the connective members? Internal forces in connective members hold the connecting parts together to keep the whole system under equilibrium. This is how you basically external forces are characterized based on the system and the fluid diagram of each and every component of the system. So this is what is the concept of your internal and external. So when many, so let us now come. Let us now discuss about truss. So truss is nothing but it consists of different members to support the static load. Okay. So most of the time this truss is a static configuration of many members. Now before that, like I also described about two force member and multi-force member. So let me first quickly tell about two force member. Two force member is nothing but it consists of equal and opposite forces. Any member which consists of equal and opposite forces F1 and F1 and their line of action also same, and we call it as a two force member. Now multi-force member, in addition to these two forces, a component has three component of forces. Let us say F1. Here also this is F1, and if you are having any transverse load which is F2 acting, so this forms three force member component. But if it is even more than three, so we can call the four force member. But in generalized term, we call such kind of members. Okay, so considering these things, the truss generally consists of two force members. Okay. second point is that all the members are connected by the pin joint at their ends. Okay. Now, when I say it consists of two force members, it means that all members are subjected to equal and opposite forces at the end. Okay, and those forces are, and the forces are either tensile in nature or compressive in nature. So it means that when you talk about truss, it consists of members which will be having just two forces. Another important point is that all the forces, external or internal, are assumed to be acting at the joints. So this is a very important assumption. It means that when you have to write down the equilibrium equations for truss, you have to consider all the forces at the joint. So it means that the equilibrium equations for the joints for the truss are written at the joint. Okay. Now, the number of equilibrium equation per member. So, if you are considering the forces at the joint, the equilibrium equation, the number of equilibrium equation will be given by summation of fx is equal to 0, summation of fy equals to 0 if it is written at the joint. Okay. So these are very important, components of the truss which makes it. It means it consists of two force members. All the forces are connected by the pin joint at their ends. All members are subjected to equal and opposite force at the end. The forces are either tensile in nature or compressive in nature. All the forces either external or internal are assumed to be acting at the joints. And equilibrium equations for the trusses are written at the joints. A number of equilibrium equations is, and how to find out the forces. The other point is that if you are, there are two techniques. First one is the find the internal forces in the member. Find the internal forces in the member. Find the internal forces in the member. There are two techniques. First one is method of joint. And second one is method of action. So basically, the equilibrium equations are written at the joints when you are using method of joints, and the number of equations that will be formed at the joint will be 2, which are summation of effect. Now when you apply method of section, so under this condition, at each joint you will have to write summation of fx0, summation of fy equals to 0. Summation of fx0 and summation of fy equals to 0. And in method of section, you can write three equations, which are summation of fx is equal to 0, summation of fy equals to 0, and summation of m at any point, at any point you can take s. So this is how like the internal forces in the members are found in trusses. So we will describe about these 2 points, but first try to understand what are the different types of trusses that exist, and then we will talk about method of joint, method of section. First of all, types of trusses. Type of trusses, there are many types, but for example, you can have something like roof trusses. So how it looks like? Let us say you will have to build a roof. Okay, something like this. Now have to design things such that how it comes up. So you can see that this particular structure, and you can have a support here, and here this. So you will have to design your truss such that you will have to anyway support it, and it looks like a if you see the temporary structures, the roof are built up by many connected members, and then you put the sheet. And so it is required how many number of members should be there to put the system under equilibrium, statical equilibrium. This is what will decide the number of internal structures. Second problem, very famous type of truss that we see is bridge truss. So how does it look like? You can assume that there is something like this. Again, there is this two. Here you will see that so this somehow forms your roof kind of bridge type of trusses. this way there exist many types of, so one can always try to refer to those. Now if you see that all these trusses, if you just focus on one, you will see that it contains 1, 2, 3, and then again it repeats 1, 2, 3, 1, 2, 3. So what is this type of, why it is required that you should go in the form of triangle? So there is something called, first of all, simple truss. What is the meaning of simple truss? Simple truss consists of three members which are connected at three joints, and rest of the members are joints to form a triangle. Okay, and rest of the members are formed by connecting two additional members at the points. So for example, let us say you start with three members and three joints. So this is called simple truss. Now when you take now two more members, let us say from this joint you connect one like this. Okay, so here it is 1 and 2, here it is 1 and 2. Now here if you start something like this, and here you start, since it is already counted, so it means that you will have to start something in this way. So this and this 2. So with this joint you are having two more. So this again forms a triangle. In a similar way here, if you see, have things like here also it is connecting, right? Then you will have something like this, and then you can fix these two. So basically when you try to, what is done here is at each joint you are connecting two members and it will form another set of triangle. This sequential form will give you this is what is called the kind of simple truss, which is formed by the repetitive use of triangular section. It has to start from one triangle and then it will end up giving you form of the simple truss. What is so much, why the simple truss is very important? So simple truss is very important. Let us say, in other way you can also say that if n is the number of joints, okay, and if m is number of members, okay, so if this m is given by 2n times 3, okay, if this m is given by this simple expression, then you can also call the truss as the simple truss. Okay, so it means that n is the number of joints, and n is the number of, like in the case of truss we call it as a two force member. So m is the number of two force member, then it is called as simple trusses. For example, let us take one example of this kind and try to see if it is a simple. So let us say here it is fixed. How many number of joints are there? 1, 2, 3, 4, 5, 6, 7. So n is 7. So it means that your 2n minus 3 will be given by 14 minus 3, which is 11. How many members are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So m is also given by 11. So since your 2n minus 3 is equal to m, this kind of truss is called simple. The moment, let's say, if we are having something like this, okay, if we are having something like this, or you can just remove one part. So in this case, you can see that their joints are same, 1, 2, 3, 4, 5, 6, 7. So like this is the second example. In the second example, you can see that n is equal to 7. So your 2n minus 3 is 14 minus 3, which is 11. Okay. And number of members are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So since m is not equal to 2n minus 3, this is not a simple truss. Okay. So we will talk about the improper, trusses, or statistical determinant trusses in the next lecture. Till now.